Hello and welcome to the following video for OCR A-Level Physics, Module 6, Particles of Medical Physics, on the concept of electrical fields, looking at electrical field strength. So if we've been successful and we've learnt in today's lesson, we should be able to define and describe electrical field strength, describe how electrical field strength can differ in different electrical fields, and calculate electrical field strength. So in this lesson, we're going to be looking at the following parts of the OCR A-Level Physics. Now, electric field strength can be shown on the electrical field diagrams as the density of the electric field lines. We can define electrical field strength as the force per unit positive charge experienced at a position in the field. Now, there are two types of field. There are radial fields, where the electrical field strength changes at different places of it, whilst you've got uniform fields, where the electrical field strength is the same everywhere in the uniform field. Now, we know this is the case for radial fields, as the electrical field line density decreases with distance from the charged object, whilst we know this is the case for uniform fields, as the electrical field line density stays the same throughout the electrical field. Now, electrical field strength is a vector quantity. It points in the direction that a positive charge would move in. So electrical fields will point away from positive charges and towards negative charges. Now remember, all electrical field quantities are defined in terms of positive charges. So there's no fundamental reason why this is, it's just the standard notation of electrical fields. Now the units of electrical field strength are newtons per coulomb. Now there are three different equations to calculate electrical field strength in an electrical field. The first one is the general equation for every field based on its definition, where electrical field strength is the force divided by the charge, or E is equal to F over Q. So for example, what is the electrical field strength around a point charge if 3.2 times 10 to the minus 19 coulombs of charge experiences a force of 7.30 times 10 to the minus 15 newtons? Well, E is equal to F over Q, so it's 7.30 times 10 to the minus 15 over 3.2 times 10 to the minus 19, so it's 2.28 times 10 to the 4 newtons per coulomb. There's an equation when considering uniform fields only, that the electrical field between two parallel plates, for example a capacitor plate, is uniform, so a charge will experience the same force wherever it is placed between the plates. So the electrical field strength depends on two factors: the potential difference between the plates and the distance between them. So electrical field strength is potential difference divided by the distance between the plates, or E is equal to the change in potential over D. Now the units of electrical field strength in this instance are volts per meter. Now this tells us the units of newtons per coulomb and volts per meter are equivalent. However, volts per meter is only used in the context of uniform fields. Finally, there is an equation for radial fields. So if we consider two charged particles, each particle is producing a radial electrical field. We know the force on each particle is given by the equation F is equal to Q1 Q2 over 4 pi epsilon 0 r squared. Now we can define electrical field strength as the force per unit charge. So E is equal to F over Q1. So F therefore is equal to E Q1. Now we can substitute this into Coulomb's law. The charges of one of the objects will cancel through the Q1, which gives us the idea that E is equal to Q over 4 pi epsilon 0 r squared. So this gives us the equation for the radial field strength. Now note, only one charge is considered, as the electrical field strength is the force per unit charge caused by being in the electrical field of that charge. So in this equation, the Q term refers to the charge the object produces in the electrical field. So if we consider a radial electrical field of an object, from the equation we realize that the electrical field strength decreases with separation from the charge, making the field with the relationship E is proportional to 1 over r squared. So this is another case of the inverse square law. Now from the field line diagram, we realize that the electrical field strength decreases with separation from the charge, making the field, as the electrical field lines are spreading apart, the field line density is decreasing. However, if the charged object is not a point charge, then the field strength is not E is proportional to 1 over r squared at all points in the field. This relationship is only true from the surface of the charged objects. So to clarify, in this case, once we get past the surface of our charged object, the electrical field strength is equal to Q over 4 pi epsilon 0 r squared. So, to clarify, the electrical field strength is the force per unit positive charge experienced by a positive test charge placed at the point of that field, and it can be calculated with the following equation. The general equation is electrical field strength is equal to force over charge. The equation for the uniform field is electrical field strength is the potential difference divided by the distance between the plates. And the equation for the radial field is that electrical field strength is equal to 1 over 4 pi epsilon 0 times by the point charge divided by the distance from the charge squared. So we can see our equation for the general definition of the electrical field strength. The equation that shows the electrical field strength between two plates is dependent on the distance between the plates and the potential difference across the plates. And then finally, that the electrical field strength exerted by a charged object or a point charge is due to the charge of the object and the distance you are away from that object. So to clarify, our general equation is E is equal to F over Q. Our uniform equation is E is equal to delta V over D, and our radial field equation is E is equal to Q over 4 pi epsilon 0 r squared. So to summarise what we've learnt in today's lesson, we've looked at the representation of electrical fields by electrical field lines, the concept of electrical field strength, E as a force per unit charge defined by E is equal to F over Q, and that the magnitude of E in a uniform field is given by E is equal to V over D. So if we've been successful and we've learnt in today's lesson, we should be able to define and describe electrical field strength, describe how electrical field strength can differ in different electrical fields, and finally calculate electrical field strength. So that brings an end to this lesson, which is part of Module 6 in OCR A-Level Physics, Particles and Medical Physics, in the topic of 6.2 electrical fields, and on our concept of electrical field strength. Thank you so much for listening and have a lovely day.